Hello everyone, this is Mashumi. Today we are going to talk about the physical world. So what is physics basically? Now human beings have always been curious about the world around them, its astonishing variety of materials and the bewildering diversity of life and behavior. Now the word science basically comes from the Latin verb meaning to know. Now whenever we are talking about science, the concept of science is as old as the human species. Now human species has been dated many thousands and millions of years before. So whenever we are talking about the earlier civilizations of Egypt, India, China, Mesopotamia, etc., these all have contributed to the rapid growth of science. In fact, towards the end of the 20th century, almost all the countries have contributed towards the rapid growth of science. Now, physics basically is a basic discipline in the category of natural sciences, which also includes chemistry and biology. The word physics comes from a Greek word meaning nature. Its Sanskrit equivalent is bhautiki, where we study about the physical world, applying different laws and concepts. Now moving on to the scope and excitement of physics. Whenever we are talking about physics, we basically think of two main domains of interest, the macroscopic and the microscopic domain. In the macroscopic domain, we talk about phenomena which are related to laboratory, terrestrial or astronomical scales. Now, this is mainly done in a branch of physics called classical physics, which includes subjects like mechanics, electrodynamics, optics and thermodynamics. Now, when we are talking about the microscopic domain, we study about it in a proper framework, that is quantum theory recently. Now here we explain the different microscopic phenomena which are related to electrons, protons and other smaller particles. Now the scope of physics is indeed very vast. At one end, it studies phenomena which are related to very small scales of length, while at the other end, we talk of phenomena which are related to very large scales of length, almost of the order of 10 to the power 26. That is when we are talking about astronomical objects. And regarding the microscopic scale, it's of the order of 10 to the power minus 14 meters. Now when we compare the two scales of length, we see that there is a difference in a factor of about 10 to the power 40 or more. This gives us an idea of the scope of physics. Now talking about the various fundamental forces in nature. The exact notion of force was first provided by Sir Isaac Newton in his laws of motion. In the macroscopic world, besides the gravitational force, we also encounter several other forces like muscular forces, contact forces. We talk about viscous forces in case of liquids. We talk about electric and magnetic forces. We also talk about force due to pressure of a liquid, the forces due to surface tension, and so on and so forth. Now, in the microscopic domain again, we have electric and magnetic forces which involve protons and neutrons. We also talk about intermolecular as well as interatomic forces at the microscopic level. Now, the four fundamental forces in nature are gravitational forces, electromagnetic forces, weak force and strong force. Let us look at each of these forces one by one. First, talking about gravitational force. Gravitational force is a universal attractive force that exists between both microscopic as well as macroscopic objects. It is a conservative central force. It is also long range but very weak compared to all other forces in nature. Now, according to Newton, every particle in the universe attracts every other particle with a force which is directly proportional to the product of the masses of the two particles and inversely proportional to the square of the distance between the two bodies. This is the famous universal law of gravitation, where if we look at the mathematical relationship, the relationship bears the form F equals G m1 m2 by r square. Here G is the universal gravitational constant whose value is given by 6.67 times 10 to the power minus 11 Newton meter square per kilogram square. So a very important constant indeed. Now, looking at the next type of fundamental force, we have the electromagnetic force. Now, whenever we are talking about like charges, they always repel each other, while unlike charges, talking of positive and negative charges, they attract each other. Now, this force of attraction or repulsion between any two charges which are at rest is called electrostatic force of attraction, and it has been seen that this force is directly proportional to the product of the charges and inversely proportional to the square of the distance between the two charges. Yes, this is the famous Coulomb's law put forward by Sir J.C. Coulomb. Now, in this way, just like statical charges can give rise to electrostatic forces, similarly, moving charges can also give rise to a force which is called the magnetic force. Now, the combined effect of electrostatic as well as magnetic force is together called the electromagnetic force. Now, this particular electromagnetic force, it arises due to exchange of particles which are known as photons. Now, talking about the third category of fundamental forces, we have weak force. Now, where does this force really exist? This force basically arises due to interactions between elementary particles during the radioactive decay of a radioactive material. So, for example, if we consider the case of beta decay, in case of beta decay, always electrons are emitted, and together with that an uncharged particle is also emitted, which is called neutrino. Now, this interaction which exists between the emitted electron and the neutrino is the weak force. Next, coming to strong force. Strong force, basically to get an idea of strong force, we can think of the particles which exist inside the nucleus of an atom. Now, these particles inside the nucleus, they are bound to each other by strong interactive forces, which are called nuclear forces or strong force. Now, this force basically arises due to exchange of particles which are called pi meshes between the protons and the neutrons. Now, coming towards the end, that is, we shall talk about unification of forces. Now, unification is a basic quest in physics. Great advances in physics have been made due to this unification of different domains and theories. In fact, it was Newton who unified the terrestrial as well as the celestial objects with the help of his common universal law of gravitation. Similarly, we have the experimental demonstrations provided by Oersted and Faraday, which tell us that the branches of electricity and magnetism, they are also interconnected. Again, it was Maxwell who unified electromagnetism with optics with his discovery saying that light is an electromagnetic wave. Now, the recent decades, they have seen much progress on this front. However, there are still many ideas which are speculative and inconclusive and need further research. In this way, physics basically explores the nature. It has put forward or it has explained the symmetries of nature with the help of various physical laws. Hope you enjoyed the video. Thank you.